Hello. Hello. Hi. I have no idea about my muscles, man. It's a foreign language to me, Jeremiah. Alright, how are we doing? Hopefully you guys are energized and ready for some math. Won't take us too long. We're only covering one section today, and that's area of a surface area of a prism cylinder, right? So, I mean, we can write the objective down first, right? So we're gonna, there we go. Calculate. Right. Surface area. We're gonna focus on prism and cylinders only. Wow. Cylinder. Okay. I guess we'll put S on both. So it's 520. You know, I don't know if you know, in Chinese this is sort of a Valentine's Day because of the way 520 is spoken in Chinese. So, if you care about that kind of stuff, something to celebrate, okay? But I mean, you don't have to care, like, you know. All right. You can mail me chocolate. You can. All right. So surface area, right? Surface area is like a area of a surface on the surface. Okay. So when you're looking at this surface area, you're only looking at the thing that exposed to the surface. There are two main things in prism. One is obviously the base, right? There are two bases when you count the lateral area. Surface area. And then the lateral area are the lateral faces. Lateral means on the side. So 1, 2, 3 on this one, and then top and bottom. So 5 faces total. The bases are top and bottom. The lateral areas are the area on the side. 1, 2, and the one that we're facing. Okay. If we're looking at oblique is like slanted asymptote. Then oblique base are the same, but the lateral obviously will be different. Okay. But today we're not going to focus on oblique prism. We're just going to focus on right prism. Okay, because right prism has more interesting things to look at. So as we continue to look, let's take a look at. I know. So happy to 520, Olivia. I don't know if you did anything special. So if you're looking at the surface area, you can use the net to calculate it, because usually the net is like what's wrapped up outside, right? So if you look at this like that, you'll get this net. Remember we talked about nets before? right? So, yeah. All right. So, let's move on to calculation. So, because when you calculate surface area, you have to always add. Okay, let's go back to that side. You have to always add up each area, right? When you calculate area. So that means A, B, C here will form a larger rectangle. Right? So then obviously this will be a large base times height, right? So base times height will then be the base will be A plus B plus C, but if you look at it at a perspective of the prism, this is actually the perimeter of the base. Okay, so perimeter is that. So when we're looking at the lateral area, which is this, plus this, plus this, originally there are 3 parts, we can use perimeter of the base times the height to just take care of all 3 at once. So that means the surface area will then be the lateral area, which is the side, 1, 2, 3, and top and bottom, the 2 bases. Okay? So that way you can have lateral plus 2 base. Okay? All right. So then, obviously, if you don't want to use the formula, then you can like add it one at a time, right? You have 5 faces and you add side by side. So 1, 2, 3, 4, 5. Just find each area and then just add them up. It's the same thing. Just like how we did this, right? There's six faces of a cube. They're all s squared, so it's 6s squared. Make sense? All right. Let's look at the next part. We're going to find the lateral area and surface area of the right rectangular prism. Round to the nearest 10, if necessary. So, should be relatively simple. You can actually add all the faces, right? It won't be that hard. But since we're learning this new formula, let's try to use it, okay? Let's try to use it. So first one I'm going to do is I'm going to find the lateral area, which is the side. Okay, 1, 2, 3, 4, 4 of them. Okay, 1, 2, 3, and then 4 on the back. And then the 2 base I'll find after that. 2 base, right? Base 1, base 2. Okay. So lateral area in this case will be perimeter times height. The height will be 14. The perimeter will be what? 9 plus 7 plus 9 plus 7. Right? So it'll be 9 plus 7 plus 9 plus 7 times height, which is 14. Work with that? Let me highlight this for you. So this is a perimeter. So I find the perimeter of the base. Okay. And then the height. That's the perimeter, right? The height is 14. Okay. All right. So that takes care of the lateral. Lateral will turn out to be what? 448 feet square, I think. 448. And the 2 base. So there are 2 bases. Let's calculate the base. So 2 times the base, right? Base would be the base area, so 9 times 7. All right, so together this is 126. Right. So then you add them up. So the surface area total is going to be 448 plus 126, which end up being 574. How are we doing? If you add all 6 faces together individually, you should get the same answer. Okay? There's no reason why it shouldn't be the same answer. You're okay? If you're okay with this, Let's try the right side. I'm gonna lift this up a little bit so you can do the right side. All right. So look at the right side and try the right side. Okay? Try the right side. Whoa. Okay. Maybe adjust the camera a little bit. Just a little bit. Try the right side. Why does it feel like it's falling slowly? Anyway, I'll just think to balance this off because my camera is slightly tilted. Give me 1 second. Oh, okay. I think it's good now. Alright. You see? It's wobbling. Should be good now. Alright. So, while you're doing this, let's take attendance. Might as well. So if you're here, just type that you're here. Okay. Still missing a few people. Is Avia here? Oh, hi Avia. All right. Sounds like all right. So let's look at this. So if you want to find the lateral area of a regular triangular prism, regular triangle means equilateral triangle, right? Or equilateral, just like that. Then there are several parts we've filled in, right? So first off, they say length is 10 each. The height is what, 20? They say, right? So if that's the case, then we can look at this like the same ways, right? So we're gonna do lateral first. So lateral is going to be these three faces. If you split it open, it's gonna look like this, right? With each one of these will be 10, 10, and 10. Why is it wobbling? And this is 20. Okay, like that. So the lateral area will naturally be perimeter times height, which is 30 times 20. You agree? 30 times 20. That's the lateral area. Okay, lateral area, which is 600 feet square. Wait, centimeters square, right? Where do I put feet? Centimeters square. Okay. and then your two bases is going to be triangle, right? Right now we're looking at an equilateral triangle, right? Equilateral means 10, 10, 10. Now, there's many ways you can find the area of this triangle. You can find a height, right? If you cut it in half. So first of all, what are the angles of these? Remember equilateral triangle angles, interior angles? What are the individual interior angles of the measures? What do they have to be? $60, right? So 60 each. So you can cut in half and make it 30, 60, 90 and do that to find the height. That's one way. Alternatively, remember we had a area formula of a triangle if we're given side, angle, side. Remember what the formula is? Can you type it in the chat if you remember? This is especially useful in this situation. Wait, remember this formula that I really like. I don't know about you guys, but I use it a lot. Whenever I can, I like to use it. Remember which one it is? Oh, wait. If I know side, angle, side of a triangle. Very close video. It has to do with AB sine C, but remember this is a triangle area, right? Triangle area. So you must have a 1/2 AB sine C. Okay? So the C would be the angle in between. Okay, so in this case it's 1/2 10 times 10 times sine 60. Okay? AB sine C. So that turns out to be like 43.3. Okay? Here. So that turns out to be 43.3. So then I'll plug it in, right? So that's the base area, right? But each base area. So it'll be 2 times 43.3, which is going to be 68.6. No, 86.6. 86.6 centimeters square, and you add them up. Okay, so surface area will then be 600 plus 86.6, which is 686.6 centimeters square. Okay. All right, let's flip it over. So next part we're going to look at is called the cylinder area. Cylinder surface area is very similar, obviously, because we talked about how similar cylinder are to prism, right? So obviously we're going to follow suit in the surface area idea as well. So let's take a look. So first of all, lateral surface is obviously, if you look at how it is, when you open this is still the lateral surface, right? Lateral surface, this thing, this wrap around, this is called lateral surface, okay? Now that lateral surface will, when you open it, cut it open and expand it into a net, this will be the rectangle, right? And this part originally was taken care of by the perimeter. Here, the perimeter is the perimeter of a circle, which we call circumference, right? 2 pi r, right? And the base area is pi r squared, so it's still the same formula, lateral area plus 2 base, but your lateral area is now represented by 2 pi r times height, because that's what this area is, right? The perimeter is circumference times height. Your base is now circular, so it's pi r squared times 2, because there are 2 bases, okay? Same thing. You have a right cylinder and an oblique cylinder. We're only looking at right cylinder today. Okay. All right. Let's look at the first one. You want to leave this in terms of pi, right? So find the lateral area, surface area of a right cylinder. Find the surface lateral area, surface area of a right cylinder. So if we look at this, and we're like, okay, well, lateral area is going to be this part. We say 2 pi, RH, right? 2 pi RH. What's the radius here? Half of that, right? So be 8, right? So 2 pi 8 times 10. So it's 160 pi. I'm gonna leave the pi here, okay? So that's the first part. 2 bases, right? So 2 times, what is the base? The base is pi r squared, right? Pi r squared. Pi is pi, r is 8 squared, right? So that's gonna be 64, so 128. So then your surface area, just add them up, right? So 160 pi plus 128 pi, so that's going to be 288 pi inches square. Oh, by the way, we all use square because it's 2-dimensional in area, right? Remember your volume was 3-dimensional, so we do inches cube. Also because when you do volume, you're doing length times width times height, right? That's 3 inches, like inches times inches times inches, so inches cubed. But when you do area, it's always length times width or base times height. And so that's 2 length units multiplied together. So you get 10 inch times 10 inch, that's 100 and inches square, because inch times inch is inch square. Okay. How are we doing? Can I get a comfort level from 1 to 10? How do we feel about this? 1 to 10. Any quick questions that you might have? Type a number for me so I understand if you get it or not. I mean, there's no point of hiding it because it's not like hiding it does any good anyway, right? $7.5 rounds up to 8. Interesting. Okay, so let's do a practice on the right. The right one is a U-try, and you kind of have to get the information first, right? So read the description first and see what you feel. Okay. I'll give you some time. Let me know when you find the answer. Oh, I have a question. I see a question. Vidya said, would solving the surface area be different for oblique cylinders? It would, because if you think about cylinders, even prisms, if it's slanted, the volume is the same. It's just base area times height. But the surface area, think about when you're opening up a oblique cylinder or an oblique prism, right? Like when you're looking at this, right? When you make it a net, the top and bottom still circles, but the side, this part, right? This lateral won't be a normal rectangle, right? It will not be a rectangle because when you open this, depending on how slanted it is, right, it will form a different type of shape. Okay, sometimes it's not even straight, right? So you kind of have to modify it. Okay, and we can't do it in normal in our normal formulas. Okay, so that's why it has to be right in surface area. Does that make sense? Okay. You have an answer, or we need some help? Nothing? No answers? Hello? So they say right cylinder with a circumference of 24 pi centimeters, right? So they say circumference is this, right? Circumference typically, we're looking at a cylinder, right? This is the circumference. That's 2 pi r usually. But they tell you the answer is 24 pi. Okay, that's what they tell you, right? So then, after you get that equation, what is your radius then? 24 pi is 2 pi r. You can divide this over and get your radius has to be 12. This is essential, okay? Without this, it's too hard. So 12. And they say height is equal to half the radius, right? So height is what? Half of that, so 6, okay? So height is 6, okay? Then you can do the rest, right? Because you want then find the lateral area. Lateral area will be 2 pi RH, which is 2 pi 12 h, which is going to be what, 144 pi, right? And your two bases is going to be 2 of the circular, which is pi r squared. In this case is pi r is 12, right? So 12 square. Oops, 12 square. So that would be 288, is that right? 288 pi. 288 pi. And then you add them up, right? So surface area is going to be 144 pi plus 288 pi. Okay, so together is 432 pi in centimeters square. Avia, does that help? Good job, Samuel. Good job, Chance. So the key point to unlock this whole problem is to set up this part. Okay, once you get this part done, recognize that circumference is 2 pi r, then the rest becomes straightforward, right? It will become the same problem, but that extra step is needed, okay? So, we're okay with this kind of problem? Similar to the previous page, right? Now the last part is the most interesting part. It's called composite figure. Now, composite figure, remember, is when you have multiple polyhedrons or multiple different solids that makes a new solid, right? Now in volume is really simple because why? Well, we just find volumes individually and then add them up, right? In surface area is not exactly that. Okay, can you tell me why that might not be the case? Why can't I just calculate the surface area of this triangular prism and surface area of this rectangular prism and then add them up? What is the problem of doing that? What would be the challenge? Or why wouldn't that work? Or would that work? They overlap, in a way, okay. You have to subtract the two, okay. So you're saying, now, let me ask you this. So you guys have some sort of understanding about, like, this part is going to be a problem, right? This part. But, should you count this part at all? Is this surface area? What is surface area? What is the definition of surface area? It has to be on the surface. On the surface, it's called surface area. So this, the one that I highlight here, it doesn't count. Doesn't count, okay? This doesn't count. In other words, when we calculate surface area, you cannot just do both and then add them up because you have overlap. Not only overlap, the overlap part is not counted in general because it's not even part of the thing, okay? So you kind of have to be a little smart about what you look at. So the way I would do it is I just add all the faces together that are exposed, okay? So I am going to add, so let's just add all the faces together then, right? Faces. So the previous period has also wonder if you can use a formula for this. You can, but once you use this formula for this, add them up, you have to subtract this middle part twice, okay? But that's a lot of work, and it's really hard to check if it's right or not. So I'm going to calculate each face, okay? So if this is 4, this is also 4, right? Hey, if this is 3, this is 4, what would this part be? What would this part be? What would this length be? 5. Right, 3, 4, 5. That is our Pythagorean triple. To find this, you can do 3 square plus 4 square square root. You'll get 5 square. I mean, you'll get 25. And square root of 25 is 5. Okay, so this is 5. This is 5. This is 2. Right. This is 3. Why do I mark these lengths? Because I'm going to calculate each individual side length. Right. So I'm going to calculate each face. Okay. So the top faces, I'm going to do this should be, originally there were 5 faces to a triangular prism, right? Top, down, right? 2 bases, both triangles, and then the lateral sides, right? There are 5 total. So now I'm just going to count 4, okay? So there's going to be, I'm going to do the triangles first. So triangle here, triangle there, right? So it's going to be 1/2 3 times 4, so that's 6. That one, same thing, 6, right? 6 and 6. I'm doing the bases first. Then I'm going to do the this one, 5 times 2. That's 10, right? This part. And I'm going to do the side, which is 3 times 2. Right, this is 2. 3 times 2. This part right here. So 3 times 2 is 6. Okay, so that's the top 4 faces, right? Bottom part was a rectangular prism. Originally has 6 faces, but I don't count the top, so there's 5 faces. So keep that in mind. You want to find 5. Okay, so 5, 3 times 4, 3 times 4 on the side. So 3 times 4, so 12, right? Plus the back is also 12. The right side is 2 times 3, 6. Left is 6 as well. The bottom is 4 times 2, so that's 8. Okay, so that's it. 5 faces, right? 4 and 5. So add them together. So the top one add up to be 28. Bottom one add up to be 20 plus 52. So add them up. It's 72 centimeters square. You get the same thing? Did I miss anything? Does that look right? 38. 17. What is this? Some secret code, Jeremiah? I know. Whatever that was, did not get. Is Jeremiah like this every class? Or just this class? Anyone wanna make a Oh. Is my bottom correct? Probably not. What is this? uh 44 maybe? I think it's 44 instead. Right? 14 20, yeah, 44. I think 44 is right. Thanks, Chance. Is that good? All right. But 72 is correct, right? 72 is correct. This is how you get caught cheating, right? This is how you get caught cheating. This is a prime example. So don't cheat because such thing happens. Okay? Like, how did he get this answer right if your process is wrong? Well, probably didn't really calculate it, right? This morning I actually did calculate it in class though. But usually second, third class, I usually don't calculate fully. It's all in my head. All right. All right. Try the right side. All right. Take a look. Give you some time. This one's also interesting. See how you can manipulate this a little bit more and get an answer. So, also talking about surface area. Oh no. Starting to lag a little bit. Frame rate's dropping a little bit. Not good, not good. Please keep up for 5 more minutes so we can get out of class, yeah? Why? Boost it up, boost it up. I think it's getting better, hopefully. I think it's just a spike. I think you're correct, Samuel. I think you're correct. All right. So let's take a look. So you have to look at the overlap part, right? So you see this part is overlap, so you don't count this part, right? You don't count this part. But there's a part up here, right? So can we just, elevator down this thing? So instead of counting this here, I'm gonna move it down to fill this spot, so I don't have to count the base at all. I'll just use this to count the base. Does that make sense? So you elevator down this thing. So all I'm adding is the lateral of this. Okay, without the base. Okay, just the lateral part. No base. Okay, just the lateral. Use my drawing a little bit to illustrate. So that's the first part I'm adding. And the second part is the whole prism. Okay, the whole prism, the whole thing. So I'm doing these two things. Why don't I have to add the top? Because the top is now moved to the bottom to make this a thing. Okay, so you kind of like flip it over. So the first part, the lateral part, is going to be the lateral part is pi r squared h. Oh, sorry, 2 pi r h. Right, 2 pi r is the circumference times height. Circumference here is going to be 2 times pi times 2. Height is 3, so that's going to be what? 12 pi. 12 pi. Okay. And this part is going to be 6 faces, right? So I'm just going to calculate 6 faces. There's 20 times 2, right? So 2 times 4 times 5. I'm going to do it this way this time to show you that they're all the same. So we have a 4 times 5. The other side is 4 times 4 times 9, and the what else? 9 times 5, right? 5 times 9, right? You have all this. Right. Each face is base times height, right? Like that, right? Base times height, that's 20. You have 2 of them. One here, one here. The other one is 4 times 9. You have here and top. 9 times 5 is this front face and the back face over here. Okay? Add them up. What's this? 202. Alright, so add them up. So your surface area is going to be 12 pi plus 202. If you simplify it, I think they didn't tell you to simplify. So if you write like 3 decimal places, so you get like 239.699 or something centimeters square. Okay. All right. All right. Any questions on this type of composite figure problems for surface area? Cohen. From the looks of it, it seemed like I don't know what you did, to be honest. How do you get 242? I don't know how you get 242. Did you type it in right? Is everyone still here? Feel like people dropped out. Anyhow, pi 2 square once? What? All right. So your homework is already posted. Obviously, I already talked about last week. So another announcement is so do your homework, okay? This homework's due Sunday, so make sure you do it. The other news is that I'm going to go to Lynbrook High School next year. It's not like you guys are affected that much anyway, since you won't have me next year anyway, right? So, but regardless, I feel like you guys should know, just in case you come look for me and you don't see me and wondering why. It's a overstaffing situation. Maya's really happy. Maya with a yes. I see you, Maya. I always knew you don't like me. It's not like I want to leave. It's Lynbrook. It's because there are too many math teachers in Mount Monte Vista and too few students. So, as the youngest one here, I get to move to a different school in the district. So, I don't even know if my room's gonna be used at all next year, so you guys can still visit the room, maybe empty room. uh, it's fine. I mean, Maya put yes, so I already know what you think, Maya. There's no voting. So yeah, I mean, thanks, Cohen. Thanks. You can have fun in class. All the math teachers in Mala Vista is pretty good. You know? I'm sure whoever you have next year can take care of you very nicely. Right? So, I mean, it's not like I lost a job or something. I'm still going to have a job. Just not here next year. Maybe I'll be back in a year. Who knows? Anyway, so I'm pretty sure people who you guys probably don't even notice if I weren't here, huh? If I didn't tell you, and then next year you came back and you're like, wait, wait, you meant Mr. Cole left? I didn't know. And it was already end of the year, Sarah said. You said yes like 2,000 years ago. Go back to the chat, okay? You'll see it. Maya. You guys will be fine though. You guys will be fine. Yeah, I mean, think about it, right? You guys wouldn't even have me anyway, right? Because you guys are either taking Algebra 2 or Algebra 2 Trig, right? And the original plan for me was to teach pre-calc and geometry anyway, so it's not like you guys really get me. So why? There's nobody at school, Parth. Don't do that. Irresponsible. Maybe I'll be back for pre-calc. Who knows? Maybe someone retire or something. You know. You guys are too funny. Anyway, so if you guys have any more questions at all, if you have some questions, you can stay. If not, maybe our finals would be like a Zoom call, and so you can see my face one more time. You know, this life. Maybe our final will be a Zoom call, and I'll see you guys take the test and see all your faces. All right. If there's no more questions, then I guess that would be all. Let's get a little bit of a sentimental music. Thanks, guys. Thanks for the sentimental. Oh, thanks, Parth. I'm glad I was the 7th best teacher you had. How do you know I sing at all? Maybe before I leave. Maybe. Just maybe. How do you know? How do you know I can sing? Who's V? Wow. VI? Who's V? Oh, V! Dude, you gotta spell your people's name correct. I was like, who's VI? Yeah. I remember V. Alright, guys. We'll continue our chat next few weeks, I guess. Feel free to leave. Goodbye. It's not time to be sad yet, okay? Goodbye. Have a good day. Homework's on big ideas. It's already open. Okay, Parth? Go check out big ideas. Big ideas. It's always there. 11.6. 11.6. It's already open. Okay? Hear me, Parth? 11.6. Alright. Dude, I'm still alive, Jeremiah. Don't do that. It's like I'm gonna die or something. Maybe you see me in like Trader Joe's or like Ranch 99 or something like that. If we ever go back there. Alright. See ya. Bye.